Welcome to my YouTube channel, and in this video we will study about functions in C++. So what are functions? Functions are, if you have what I have written over here, functions are a block of code performing a specific task. To what does this means? This means that you want to perform some work repetitively, and if you have to perform that task repetitively in your code, then one approach of solving that problem will be that you write that specific piece of code every time whenever it is required. Or the other approach could be that you create a function, and then whenever you require that task to be performed, you call that function. Okay, so if you're not able to get it, let us try to understand this with the help of some practical example. For example, I have already told you how to find the maximum of three numbers using if else and nested if else. I have already told this program. So program is self obvious. I have to find the greatest of A, B and C, and if A is greater than B, then I will not take into consideration B. I will only then compare, because A is already greater than B, then I will compare A and C, and if A is greater than C, then A will be greatest, else C will be the greatest number. So this is a very simple program to find the maximum among three numbers. But is there any specific way by which we can reduce the lines of code, how many number of lines, or the complexity of this code? Is there any way by which we can do that? Yes, there is a way. If you observe, we are finding the greatest of two numbers, and this we are doing over here also, this we are doing over here also, and this we are doing over here also. So there is a specific block of code that is being executed, that is required in your program more than once. So why not create a function out of it? And for example, I create a function, and suppose so how do you create a function? First of all, you specify the return type of the function, then you give the name of the function. So suppose I say the name of the function in my case is max, and then you specify the argument list for the function. Suppose there are two arguments. Suppose I will say integer x comma integer y, and this function is very simple. What it does is that it finds the maximum of x and y. For example, if x is greater than y, it return x, else it returns y. This is a very basic function. I have created this function, and it just finds a maximum of two numbers. Now I don't want to write all this piece of code, so I will remove it. Now, is there any simple and sweet way to perform the same task that we were executing before? Is there any way? Yeah, there is a way. Turns out there is a way. What way is there? I can write what? I can write like this: max A comma max B comma C. If I just write it, for example, if I just write it, see in one line what task I was executing, with writing multiple lines of code. I have just written this one line of code, and it is performing the same task. If you try to run it, you will get the maximum number. For example, if I just go and clean and build this application, and then when I go and run this application, see, you are getting the maximum of all the three numbers. See here, A is equal to 10, B is equal to 5, and C is equal to 8, and the maximum value is what? Maximum value is 10. So it is getting me what? It is getting me 10. And if you are not able to understand how this is functioning, then you can just see, for example, I'll just take the pencil, and so max is a function. So all right, so here I have a function. What is the name of the function? The name of the function is max, and it is taking two arguments, suppose x and y, and it is returning. So the return type is what? Return type is int, and it is returning the greater of what? X and y. So I have called what? I have called max C. I have called max, and then again I have given what? Max of what? B comma C. So what is gonna happen is that First of all, this inner max will be resolved, and it will give a call to which function? It will give a call to this max function, and it will fetch me the greater of what? Greater of b and c. So in this case, which is greater? C is greater, so it will return me what? It will return me c. So it will eventually resolve to what? Max of a comma c. And now it will compare a and c. So a is equal to what? A is equal to 10, and c is equal to what? C is equal to 8. So it will find the maximum of 10 and 8, and then it will return me what? It will return me 10. So you can see this program, if you just observe, this piece of code is very simple to understand, and it's very sweet and simple. You know, you don't have to write you don't have to write code like duplicate code in your program. So it is very simple to understand and debug. And now if you want to find it, for example, if you want to find the minimum, then you can declare, you can create another function. So let us take a look at another very sweet example in which functions use will become very clear. So let me just go to. I have already created this program. This program is basically this. What this program does, I'll just tell you. I'll copy all this, and I'll go to. Okay, here I go, and I'll remove all this. All this is not required, and I just paste it. So what this program is doing is it is finding the the number of prime. It is finding all prime numbers between 3 and 100. So what? See, between 3 and then between 100. It is finding all prime numbers. So what it is doing exactly is like that. First of all, I need to run a loop from 3 to what? I need to run a loop from 3 to 100. And then I get every number, and then individually I check whether that number is prime or not. So I have already explained this program of finding whether a number is prime or not. See, the num is the number in which I need to find whether it is prime or not, and then this inner for inside this for loop body, it is just finding whether num is prime or not. Okay. So I've already explained this program. I'll not explain it again, but you can see that this program tends to be little complex, and on first go it is very difficult to see, observe, and understand what this program is doing. But you can just observe, like num is taking values from 3 to 100, and in each and every case it is finding whether num is a prime number or whether num is not a prime number. Let us try to run this program. Suppose if I go and clean and build this application. And now if I go and run this application, okay, I think alright, here I just need to add some space. Let us again clean and build this application. Suppose I clean and build it. And now if I go and run this application, it will work fine. Yeah, so it is getting me all the prime numbers between 3 to 100. Okay, there is one is flaw. I think it should be less than or equal to. Okay, here also I need to mention what less than or equal to, because I want to find inclusive all the ranges, 3 and 100 included. I want to find all the prime numbers. Okay, so this is self-explanatory. I'll again try to run it, so that output comes out to be verified. And then if I run this program, see, you're getting all the prime numbers between 1 to 100. All right, but now I want to make this program more readable and more understandable. So let us do one thing. Let us create a function, and suppose the name of the function. What the function essentially does is it takes a number as an argument and find whether the number is prime or not. So let me create a function is prime, and this function takes a number as an argument, that is of type what? That is of type int, and it returns a char. For example, I say it returns a char as a return type. So what does char means? If it returns a y, then it means yes, that means the number is prime, and if it returns n, that means the number is not prime. Okay, so this is how the program exactly runs. And now what I will do is that I'll just copy all this piece of code. I do not need I'll just tell you, I'll just copy all this piece of code, and what I'm going to do is I'm just pasting it over here, and I check return y, else return, and then I say what? Then I say n. Okay, so let us try to understand this, how this is prime function is working. It is taking a number as an argument. It is taking a number as an argument, and it is running a loop from where? From which position? From 2 to the number divided by 2. And I have already explained this program. If I completely divides a number, and that means the number is not prime, and for that case we increment the value of count. So if the value of count remains to be 0, then the number is prime, else the number is not prime. See, I'll just quickly demonstrate this. For example, suppose the number is what? Suppose the number is 7, and then the loop will run from what? 2 to what? 2 to 7 divided by 2. That will be equal to what? That will be equal to 3. Okay, so it will run for 2 and it will run for 3, and 7 divided by 2. 7 divided by 2, is this equal to 0? No, it is not equal to 0. It is not equal to 0. Again, 7 modulus 3, is it equal to 0? No, it is also not equal to 0. So the value of count in this case will remain to be what? Count was initialized to be 0, and it will remain to be what? Count was initialized to 0. So count in the case of 7 will remain to what? It will remain to be 0. So once it gets out of the body of the for loop, it is checking whether count is equal to 0. Yes, it is equal to 0. That means the number is what? That means the number is prime, and that is why I am returning what? I am returning yes. See, this is the name of the function, is prime, and it is just checking whether the number is prime or not. Else it is returning what? Else it is returning what? N. Let us take another example. For example, I take 8, then the loop will run from what? 2 to 4, and 8 modulus 2 will become what? 8 modulus 2 will become equal to 0. In this case, the value of count will become what? Count will become 1. Then it will run for 3. Okay, 2, 3 and 4. Then it will run for 3. 8 modulus 3 will not be equal to 0. 8 modulus 3 will not be equal to 0. But once it runs for 4, 8 modulus 4 will again be equal to what? It will be equal to 0. So the value of count will become what? It will become 2 in this case. So again, once it gets out the body of the for loop, it will check count is not equal to 0. So it will return n in the case of what? In the case of 8. So it is gonna check whether a number is prime or not. Okay. So I'll just clear all this. And now my task is very simple. What is that simple task? I just need to check this. What do I need to check? I just need to call this function what if what is prime, and is prime what? Num. Is equal to what? If it is equal to yes, then I say cout num, and then I give a space. Okay, see, now which program is more readable to understand? See, now you are able to get it. The loop is running from 3 to 100, and for each number it is finding whether the number is prime or not, and if it is prime, then I am printing the number. So now the program becomes much more readable to understand and debug. See, clean and build. And now when I go and run this application, see, again it is printing the numbers from 3 to 100 that are prime, but now the program logic is much more simple, and it is much more easier to understand this. So the program has become much more modularized, so it has become more modularized and more understandable. So this is what is the advantages of using functions. Okay, so in the next video we will continue our discussion of functions, and we will see what is function prototype, what are formal and actual arguments of a function, and then we will study about the default argument of functions. Okay, thank you so much for watching my videos.